Go.
Okay. So first thing I'm going to do is I'm going to label my points. So I don't need to do the whole shape, but for this one we'll go to that point there. So I'm going to call this A, B, C, and D up the top. 1, 2, 3, and 4 down the bottom. That's enough of the shape that we can then use the dimensions to make the rest of the shape. So the top half is called A, and this one's called 1. Now I'm going to label that A and that 1. Now in this case here, although these two lines are both vertical, they're not perpendicular to the viewer. So as a result, we need to flip them. Now, if we call this the X direction and this the Y direction, our horizontal, our hypotenuse is going to be X squared times Y squared, the square root of X squared plus Y squared. Okay, so what I'm going to do to get that shape is I'm going to take this here is the distance. I'm just going to measure off. I could measure it off with my ruler, but it's easier to actually use the compass to mark out this dimension. So that's the distance of A1 in the horizontal direction. That's this distance of A1 in the vertical direction. And this is the true length, the hypotenuse. That's the true length of A1. True length A1. Which if I measure is 40 millimeters, and if I measure here is 40 millimeters. Okay, so they've given us that one. Now the next ones we get away pretty much for free. If we go, this is AB and 1, 2, because we know that these are 45 degrees from the seam, they always give us something that's perpendicular to the edge. We can just measure those straight off. So what we can do is we can actually just use our our set square rather, and just draw off the edge, and because we know this one here is true, these two sides are both true, we can just use AB as a true length already. In this view, AB is true. Gives us AB. And this one here gives us 1, 2. And with that, we now have one side complete. We have B and 2. Now to get to the next location, to get to C, although we know one side, we know BC, we can see BC is a true length. It's a dot in this view. I'll just label the other points. B, C, 2, 3, 4, and we're not interested in that point, and D. So because BC is a dot in this view, we know that BC is true. So we can take that dimension, and if we know BC is going to exist somewhere on that line, somewhere in that line BC is going to be found. The thing is though, we need to triangulate that by knowing, we know the length of 2C, so from 2C, this is the top view, this is the horizontal view, or this is the X value, this is the Y value, but to find it, what we need to do is we need to rotate this until it becomes horizontal. Now that's the horizontal view, that's perpendicular. If we extend that down to where it exists on this plane, we can then say this here is the true length, 2C true length. We can measure off this distance here. This is the true length 2C. We know that C exists somewhere on this line, 2C. So where we know 2C fits on this line and BC exists somewhere on that line, we know that C has to be here. We can then draw that line as a dark line and say C. Okay, now that we know where C is, we can now find point 3. To find point 3, we have to rotate 3C until it's perpendicular. So at the moment it's not perpendicular. I take the distance 3C and I rotate it till it's perpendicular. I now drop it down to the next view. I then connect that, and I can write 3C true length on the line. I measure the line and I know that 3C exists somewhere here. I know where C exists. I know C3 exists somewhere on 3C exists somewhere on this line. 3C is somewhere there. I know that 2, 3 is already a true length. 2 because it's a dot in this view. 2, 3 is a true length. From 2, I get 2, 3 exists somewhere in this length. Getting a line. That gives me that line. I have to do one more dot. I have to find 0.4. I already know the length of 3, 4 is a true length because it's perpendicular in that view. 3, 4 is a true length. I know where 0.3 is. So I know that 3, 4 is going to exist somewhere on a line that is this far away from 0.3. So 0.4 lives somewhere there. I know where C is. So if I know where 4C is, I can triangulate. If I know 4C is somewhere there, I can get a true length of 4C by rotating the angle down. So 4C is somewhere the length of this. So I'm running 4C true length. 4C is a true length here. So if I know where point C is, and I'm looking for 4C, 4C is going to exist somewhere on this line. 4C exists here. 3, 4 lives there. So 0.4 has to be where those two lines meet. I now have 0.4. I have one last point to find. I have D. So CD is a true length in this view. I don't need to do anything to it. CD is a true length. CD lives somewhere on that line. I need to find 3D, or I could go actually, what I'll do is 4D. 4D is not a true length, so I have to make it a true length. I make it a true length by taking the distance here, I rotate it until it's now perpendicular. I drop it down, comes to there. I'm just going to draw an arrow out to say 4D lives there, and that's 4D true length. I mark it, and I know D has to exist somewhere on that line. 4D lives somewhere there. So CD and 4D meet at that location, therefore that's where point D lives. D, and that is my true length. Now, one thing that I probably shouldn't wait till the end of the thing to say, but if you have no idea what you're doing, here's my recommendation, right? Let's say you have no idea what you're doing, you've forgotten everything, you didn't study true lengths, right? Here's my risky recommendation. I'm going to draw this, right? First of all, well, I know these two I can just get away with just drawing perpendicular, right? These ones here I can get away with. You get the first two for free.
Which lengths are those?
The two that are directly adjacent to the seam, you can just measure off because you know that they're actually going to be perpendicular. Got it. Yeah. So those ones you get for free, right? Then after that, let's say you just don't want to do anything, right? What you could do is you could just say guess them, right? And just start saying, oh, well, there and there. All right. And look, I shouldn't be saying this on a video, but I'm going to say it anyway, right? If you just go with a couple of things like this, what it does is in a 4-mark question, right? What it does is in a 4-mark question, it shows that you knew some idea of what to do. Some idea, and maybe we'll end up cutting that part out, but this is some idea.